Estimate the mean free path and collision frequency of a nitrogen molecule in a cylinder containing nitrogen at, at 2 atm and temperature at 70 degrees Celsius. Take the radius of a nitrogen molecule to be roughly 1 angstrom. Compare the collision with time. The molecule moves freely between two successively collisions and take the molecular mass of nitrogen as 28.0. So we'll see the solution part of this question. So we know that the mean free path the mean free path is equals to 1.11 into 10 raised to the power minus 7 meter. Collision frequency is equals to 4.58 into 10 raised to the power 9 per second. The unit of frequency is second inverse. Okay, so successive collision time is approximately equals to 500 times of collision time. It's like approximately 500 times of collision time. So the pressure inside the cylinder containing nitrogen we denote it by P. So P is equals to 2 atm and 1 atm is equals to 1.013 into 10 raised to the power 5. So 2 atm is equals to 2.026 into 10 raised to the power 5 pascals. 1 pascal is equals to 1 newton per meter square. Temperature inside the cylinder. The temperature inside cylinder we denoted by T is equals to 70 degrees Celsius, and in Kelvin scale it's equals to 290 Kelvin. So for it to convert into Kelvin, we just add it by 273. The radius of nitrogen molecule, the radius of nitrogen is N2. N2 molecule we take it as R is given as 1 angstrom. 1 angstrom, like it's equals to 10 to the power minus 10 meter. So 1 into 10 to the power 10 meter. Excuse me. So the diameter diameter D will be equals to 2 into 10 raised to power minus 10. So it will be equals to 2 into 10 raised to power minus 10 meters. So the molecular mass of nitrogen, molecular mass of nitrogen is N2, is equals to 28 grams, and we can write it as 28 into 10 raised to power minus 23 kg. So M is equals to 28 into 10 raised to power minus 3 kg. So the root mean square velocity, the root mean square velocity of nitrogen. The root mean square velocity of nitrogen is given by what's the formula of VRMS? VRMS is equals to root of 3 kT by M. So here K is equals to Boltzmann constant. Boltzmann constant. Also, we know that we can write VRMS equals to root of 3 RT by capital M. Here R is universal gas constant. R is universal gas constant, and its value is equals to 8.314 joule per mole per Kelvin. So we know the value of R, we know the value of T. So I will again write the value of VRMS. Formula of VRMS is equal to 3RT by capital M. So we know the R, we know the T, and we also know the value of M. So we just substitute all these values here. So 3 into what is R? 8.314. What is the value of T? 290. And M is equal to 28 into 10 raised to power minus 23 in kgs. Okay. So after solving this, the value of VRMS is 508.26 meter per second. So the mean free path length, the mean free path L is given by relation L equals to Boltzmann constant K into T, temperature, divided by root of 2 into D square, diameter square, into pressure. So we have to calculate the mean free path length. Okay, so here K is Boltzmann constant, as I told you. Boltzmann, you know that, and its value is equals to 1.38 into 10 raised to power minus 23 kg meter square second per second square per Kelvin. So we'll just substitute all the values inside this formula of L. So K is equals to 1.38 into 10 raised to power minus 23. Temperature is 290 root 2, and D square is 3.14 into 2 into 10 raised to power minus 10 whole square into pressure. Pressure is 2.026 into 10 raised to power 5 pascals. This is in pascals. So 1 pascal is 1 Newton per meter square. So when we solve this, the value of L comes out to be 1.11 into 10 raised to power minus 7 meter. So the collision frequency. What is collision frequency? Collision frequency is equals to VRMS divided by L. So when we put substitute all the values down here, it will be equals to this divided by L. L is 1.11 into 10 raised to the power minus 7, and that's equals to 4.58 into 10 raised to the power minus 10 raised to the power 9 per second. So we need to calculate collision time. So collision time is given by its simpler time we calculate, so distance divided by velocity, d by vrms. So d is equals to 2 into 10 raised to power minus 10 upon what is vrms, 508.226, and that's equals to 3.93 into 10 raised to power minus 13 second. So time taken between successive collisions T dash, we denoted by T dash, is it's equals to L by VRMS. And when we substitute all the values here, L is 1.11 into 10 raised to the power minus 7, and what's the value of VRMS? 508.26, and it's equal to 508.26, and the value is equals to 2.18 into 10 raised to the power minus 10 seconds. So what's the value of T dash by T? Therefore T dash by T We know both the value. So t dash is 2.18 into 10 raised to the power minus 10 divided by 3.93 into 10 to the power minus 13, and that is equals to 500. Hence the time taken between successive collisions is 500 times. So t dash by t is 500, so t dash is 500 times the time taken for a collision. So that's the solution of this problem.